Mom, I'm home.
Your study partner called. He can't make it this afternoon.
Oh no! And my science test is tomorrow!
I'll help you get a good grade on that test.
Who are you?
I'm Marko the pencil. We can study for your test in Marko's Super Science Station.
That sounds cool, but where is it? And how do we get there?
Just close your eyes and repeat after me. There's no subject like science. There's no subject like science. There's no...
Huh?
Just kidding.
Hey! What's going on? Whoa! This is no ordinary science lab!
You've got that right. Come this way.
Wow! Ooh.
And have a seat.
I can't wait to do some experiments in here!
Hold on. Before you do anything in a lab, you need to learn about science safety. Plan ahead by reading through the steps of an experiment. You should learn how to use any equipment you'll need. And if you don't understand something, ask before you start. Be neat and organized. Keep your work area clean. If you have long hair, you should pull it back in a ponytail, like my cousin Vito does.
Hey, all you ladies out there.
Get out of here, what are you doing? Keep any loose clothing out of the way. If you are wearing long sleeves, roll them up. If you have an accident or see one, report it to the person in charge right away. This includes anything that is spilled or broken, and is especially important if someone gets hurt. Watch your eyes. It's harder than I thought. Wait a minute. This is no way to do a science experiment. Let's change this to protect your eyes and skin. Make sure you wear safety goggles if they are provided. But if you get something in your eyes, tell an adult right away. And if anything gets on your skin, wash it off immediately. No eating or drinking during a science experiment.
What about me, Marko?
Sorry, Sippy. This includes you. When you are doing a science experiment, never eat or drink anything, especially the substances you are using.
Okay.
I hope that's the last straw. Be careful with electric cords and equipment. Make sure that the cords are out of the way. When you finish the experiment, don't ever disconnect electrical plugs by pulling on the cords. Doing that can cause a short.
Hey, who are you calling short?
Not that kind of short. An electrical short.
Oh, okay then.
Sometimes hot plates or Bunsen burners are used in experiments, and they can get really hot. When handling them, use protective mitts or ask an adult to help you. We don't want anyone to get burned. And finally, when you finish your experiment, clean up after yourself. Put everything away in its proper place, wipe down your work area, and wash your hands.
Now, can we do an experiment?
Well, no one starts in just blindly experimenting, except maybe a mad scientist.
Yeah. I guess there should be a method to the madness.
There is! It's called the scientific method.
We learned about that in science class, but I can never remember all the steps.
Sometimes I'm a little in the dark about that too.
What's going on?
Maybe I can shed some light on the subject.
Who said that?
Ta-da!
Why, it's my good friend Lumina.
Hiya, Marko. Who's the cute kid?
This is Kevin, and he needs a good way to remember the scientific method.
Well, I can show you how with a little light music.
Question.
Ask a question about something you want to know. Make sure it is testable, though.
Gather.
Observe things around you or collect information from the internet, books, articles, or an actual location.
Just make sure that any reference you use is scientifically based.
Hypothesize.
About the outcome, make an educated guess. Base your predictions on cause and effect.
Experiment.
Design and perform an experiment next to put your hypothesis to the test.
Follow written instructions and record what you are seeing. Multiple trials make the experiment more convincing.
Conclude.
Analyze and interpret the results that you get. You might have to modify the hypothesis and the experiment.
Report.
Let others know of the discoveries you've made. Your data might need to be rearranged. Question. Gather. Hypothesize. Experiment. Conclude. Report.
Question. Gather. Hypothesize. Experiment. Conclude. Report. Question. Gather. Hypothesize. Experiment. Conclude. Report.
I can see how the scientific method really matters.
It certainly does. But let's move on to something of a different matter. We're off to the Matter Learning Center.
Whoa! I think my chair is moving by itself!
Don't worry. It will probably stop by itself too.
Probably?
Well, hello there.
Oh, hi, Belle. I was just taking my friend Kevin over to the Matter Learning Center.
Nice to meet you, Kevin.
It's very nice to meet you. Now I know this chair can stop.
You two must be studying physical science today. I hope you'll come and learn about life science with me another time.
We will. Ciao for now.
Ah!
Ah, here we are. Let's review a few things that matter.
I've learned that matter is anything that has mass and takes up space.
That's just what I was going to say. But there are many other things to learn about matter. Matter is made up of tiny building blocks called atoms.
Tiny, huh? Are they smaller than a flea? Or a grain of sand?
Oh, much smaller.
How about a blood cell you can only see under a microscope?
Atoms are even smaller than that. Each of those things is composed of millions and millions of atoms. An atom is the smallest amount of an element you can get that still has the chemical properties of that element. Scientists have built special tools to look at atoms. But even with an electron microscope, atoms still look kind of fuzzy. So let's look at this model of an atom of helium. That's the gas that makes balloons float.
Ah, it looks like the tiny atom is made up of even smaller particles.
That's right. The nucleus, or center of the atom, is made up of protons, which have a positive charge, and neutrons that don't have any kind of electric charge. The number of protons always tells us the type of element. This atom is helium because it has 2 protons. The tiny particles zipping around the outside of the nucleus are called electrons. In a real atom, they move much faster. Electrons have a negative charge.
Protons positive, neutrons neutral. Protons positive, neutrons neutral.
And outside, the negative electrons reside.
Protons positive, neutrons neutral. Protons positive, neutrons neutral.
And outside, the negative electrons reside.
So everything around me is made up of atoms. Does that mean I'm made of Kevin atoms?
Oh, no. Some things like helium, oxygen, and gold are made up of one kind of atom. Things made of only one kind of atom are called elements. But sometimes different kinds of atoms will bond together to form molecules. For example, a water molecule is made up of 2 hydrogen atoms and 1 oxygen atom.
Oh yeah! I've even heard people call water H2O. And water is completely different from hydrogen or oxygen by themselves.
Now, water, like all matter, can exist in different states.
I've learned about states of matter: solid, liquid, and gas.
That's right! And matter can change states under certain conditions. Let's consider water. In its solid form, water is called ice. But what happens when ice gets too warm to remain as ice?
It melts. Oh, it changes state from solid to liquid at a certain temperature.
The temperature at which it changes from solid to liquid is called the melting point. Now, if you heat the liquid water up to its boiling point, it will change to its gas state, which we call water vapor or steam.
Like in clouds.
Correct! Each type of matter has its own boiling point and melting point. If you have 2 pieces of the same matter, under the same conditions, they will have the same melting point and the same boiling point.
I see. No, not I see. I see.
That reminds me, the point at which the liquid water turns to a solid is the freezing point. The melting point, boiling point, and freezing point are only some of the properties of matter. Physical properties are things you can detect with your senses.
Like when you touch something and it feels cold? I touched a doorknob outside on a cold day and it felt really chilly. But when I touched the door, it didn't feel as cold.
I'll bet the doorknob was metal and the door was wood.
You're some kind of mind reader. So why did the metal feel colder? Aren't the doorknob and the door the same temperature?
Yes, but metal is a better conductor than wood. Heat leaves your hand more quickly when you touch the doorknob, so the metal feels colder than the wood, even though they are the same temperature. Wood is a better insulator than metal. If you had on mittens, the metal would not feel as cold, because mittens are good insulators too.
So that's another property of matter.
And it's called conductivity.
Metals are also good conductors of electricity.
I suppose you'd know about that, Lumina. Let's think of some more properties of metals.
They tend to be shiny, especially if you polish them.
You're talking about luster. Another fun property of metals is malleability.
Ooh, that means that metals can be bent and shaped into important things, like wires.
There are so many more properties of matter. Color, odor, density, hardness, magnetism, and texture, just to name a few.
What's this? Looks like you boys have been making some physical changes.
Huh? What do you mean?
This water boiling is a physical change of matter. Even though the state changes from liquid to gas, the molecules are still H2O, still water.
I get it. Physical changes don't change the chemical properties of matter. Like if I break a wooden pencil in half, Both pieces are still made of wood.
Why don't we think of a different example? How about crushing a can or forming metal into wires?
Those are physical changes too. But if you really want to mix things up, you can make a chemical change. Take a look at these nails.
This one is all rusty. But how's that different from breaking a stick or crushing a can?
Rust is a chemical change. The iron in the nail combines with oxygen in the air to make a new molecule with different properties than iron or oxygen alone.
And if we burn this paper inside the beaker, that will cause a chemical change too. The ashes are different from the paper on the molecular level. We've made a different kind of matter with a chemical change. So far, we've learned a lot about pure substances, things that are made of a single element or compound.
Like helium. It's made of only helium atoms.
And water is made up completely of H2O molecules. But some kinds of matter are combinations of different atoms and molecules. We call these things mixtures.
But wait, isn't water just a combination of hydrogen and oxygen atoms? How is a mixture any different from that?
With a mixture, you can separate out the parts with a physical change. Let me show you what I mean. Suppose we are making a fruit salad. I like blueberries, strawberries, and almonds. We can mix those together to make a salad. This salad is a mixture.
I understand what you're getting at. You could pull out the almonds if you didn't like those.
What are you, nuts? Just kidding.
As I was saying, you can separate the salad back into blueberries, strawberries, and almonds, so the salad is a mixture. But you can't separate water back into hydrogen and oxygen with a physical change.
Bravo! Now check this out. Let's pour salt in this beaker of water. Salt and water are each pure substances, but they blend together to make a special kind of mixture called a solution. In this case, the solution is salt water.
That's a mixture? How are you going to take the salt back out?
With a physical change. We'll boil the water. Remember, state changes are physical changes. The water evaporates into vapor and leaves the salt behind in the beaker.
Oh, that really was a mixture. Got any more mixtures up your sleeve?
Well, I don't have any sleeves. But another mixture is right under your nose, and in your nose, and down in your lungs.
Ah, air must be a mixture too.
Smart boy! Air is a mixture of mostly nitrogen and oxygen.
Some metals are mixtures too. We call metal mixtures alloys. Bronze is an alloy of copper and tin.
I suppose copper and tin have different melting points.
That's really bright of you. That's how we can separate tin and copper from a bronze alloy. Just heat it to around 240 degrees centigrade. That's hotter than the melting point for tin, but way below the melting point for copper.
We're gonna need a bigger hot plate!
Learning about matter was a blast, Marko.
Well then, let's blast off to the Electricity Learning Center. Here we can learn all about electricity. Electricity is a kind of energy that we can find in nature. But we can also produce electricity to do work. Look at the terminals on this battery. Tell me what symbols you see.
I see a plus sign and a minus sign.
That's right. The plus sign shows the positive terminal, and the minus sign is for the negative terminal.
Say, that reminds me of something we saw at the Matter Learning Center. In an atom, protons have a positive charge and electrons have a negative charge.
Correct. Now it just so happens that opposite electric charges attract each other. So, if we connect this battery to a light bulb,
Electrons will move from the negative terminal to the positive terminal.
You're so bright. And so is this light bulb when electrons move through it. We call the moving electrons an electric current.
we've created a simple circuit with the battery, the light, and the wires. The wires are made of metal, so they conduct electricity well.
Let's add a switch so we can conserve our battery.
Good idea. When we open the switch, the circuit is broken and the light goes out. Now let's have some fun. We can take these wires off the switch to see what materials will conduct electricity.
Aha! If we touch the wires to something that is a good conductor, electricity will flow and the light will come on.
I'm so proud of this guy. Let's try this eraser.
That doesn't work. Looks like rubber is a good insulator.
Yes, it is. How about these?
No dice. I'll bet those are made of plastic. Another insulator. Now this paper clip is made of metal.
I'm thinking this will work. Yep, metal is a conductor. Hey, Marko, what about you?
Hold on a second. Phew! It looks like wood is an insulator. Here, put this on.
Okay. What's this thing for?
Oh, nothing much. It's just a metal helmet. I want to iron out a few things.
Whoa!
Bada bing!
Look at all these different kinds of magnets.
Aren't they great? I like magnets because they are magic. I have no idea what makes them work, and I don't care.
Marko!
Just kidding. Magnets are objects or materials that have a magnetic field. This field can attract magnetic matter like iron. Magnets can also repel or attract other magnets.
How can they do both?
It's all about the poles, kid. All about the poles.
Hey, Tara! I was just teaching Kevin here about magnets.
Well, I know a thing or two about magnetism.
Really?
Sure. The Earth has its own magnetic field, don't you know? And just like planet Earth, all magnets have a north pole and a south pole. The like poles of magnets repel each other. But the north pole of one magnet will attract the south pole of another magnet.
Looky here!
How are you doing that?
These ring magnets are turned so that their like poles are toward each other. So they repel. The magnetic force is strong enough to make them float. If we flip one of the magnets over, like so,
Now the top two attract.
Just like I told ya.
there are permanent magnets that keep their magnetism over a long time, and temporary magnets that lose their magnetism more quickly. In fact, we can make a temporary magnet by stroking this needle with a strong bar magnet. If we stroke in the same direction many times, the needle will become a temporary magnet.
That's cool. But why would we make a temporary magnet out of a needle?
Glad you asked, kiddo. We can use this magnetized needle to make a compass. The needle will line up with the Earth's magnetic field and point toward the poles.
Speaking of poles, the magnetic field is always stronger close to the poles of a magnet. These dark lines represent the magnetic field around these magnets. See how the lines are closer together at the poles?
Sounds like we've gotten everything ironed out about magnets.
Not so fast! Electromagnetoma jumbo! I told you there was a magic in magnets!
Yeah, right. What's that contraption?
Ooh, it's an electromagnet. When an electric current passes through these coils, it causes the nail to become a temporary magnet.
And the more coils, the stronger the magnetic field. A battery with a higher voltage will make a stronger electromagnet too. because more electric current will flow through the coils.
Electromagnets are really special. You can turn them on and off. We can use them to make a crane for moving iron in a junkyard, or to make a lock with a remote switch. Electromagnets are used in motors, and even for generating electricity.
Just a minute. There's something fishy here. When I turn off this electromagnet, the nail still attracts these paper clips. Sort of.
Well, electromagnets may hold some of their temporary magnetism when they are turned off, but they're much stronger when electric current is flowing through them. If electromagnets are left off, they will eventually lose all of their magnetism. Let's move on to the Motion and Gravity Learning Center.
Okay, but no more helmets. I'm not gonna fall for that again.
Oh, you won't need a helmet.
Hey! Yo!
Ah, good. You made a safe landing.
I don't think I understood the gravity of what I was saying.
Oh, very punny. Gravity can mean seriousness, but in science, gravity is a force of attraction.
Kind of like magnetism?
Well, no. Magnetism and gravity are completely different forces. Magnetism can pull objects together or push them apart. Gravity is a force that pulls any two objects with mass together. No matter what they are made of, both objects get pulled towards each other just because they have mass.
The strength of the gravitational attraction between two objects depends on two things. The first factor is mass. That's a measure of how much matter is in an object.
The more mass something has, the harder it pulls on other objects. That's why everyone around the globe can stand on the ground without falling off the earth. The mass of the earth is so large that she holds us close.
What are you trying to say?
Gravity is what makes us fall sometimes too. Like when a trap door opens.
You're right.
Well, the second factor that affects gravity is distance. The strength of gravity between two objects gets smaller the farther apart they are.
That just makes sense. The Earth's gravity pulls really hard on me when I'm standing on it.
But what if you were on the International Space Station? Or out on a spacewalk? Gravity wouldn't be so strong then.
I could float around almost weightless.
Or what if you were on the moon?
Well, I wouldn't be weightless, but I would weigh less than I do on Earth. And I could jump really high!
That's because the moon has a smaller mass than the Earth. Your mass stays the same, but you'd weigh less because of the lower gravitational pull from the moon.
Exactamundo. Now, obviously, gravity will affect things that are moving.
Sure, if I throw a ball up in the air, gravity will pull it back down.
Right. You give the ball a speed and a direction, that's its velocity. The ball's speed or rate of travel may be fast at first, but the pull of gravity will slow the ball down and then accelerate it back toward the ground.
Acceleration is the change in velocity. When something speeds up, we call that acceleration.
And when something slows down, we call that deceleration.
Now, suppose your ball hits the ground and starts rolling down a hill. It will accelerate again, but what if it rolls onto some flat ground?
It will keep rolling for a while. That reminds me of something. An object in motion tends to stay in motion.
You're talking about inertia. An object at rest will tend to stay at rest, and an object in motion will tend to stay in motion, unless a force is acting on it.
I know that ball won't keep rolling forever. Something slows it down.
That something is called friction. Friction is a force that appears whenever two things rub against each other. The friction of the ground against the ball will slow it to a stop.
Friction happens whenever two things are in contact. even when the ball is moving through the air.
That's called air resistance. Even though the air molecules are tiny, they still cause friction on the ball.
We've talked about motion so much, my head is spinning.
Don't be silly. Let's get you ready to go to the Light and Energy Learning Center.
Okay, I'm all set.
Are you sure?
Oh yeah! Oh yeah! Phew, that was different.
You bet it was. And energy comes in many different forms. Heat, electric, sound, chemical, mechanical, and light are some of the kinds of energy we use. Energy is the ability to do work.
Can you guess my favorite kind of energy?
Wow, let me see. Is it light?
You got it! Light energy is released by light bulbs, the sun, and fire.
All those sources also release heat energy.
I know that's true. After it's on for a while, a light bulb can be pretty hot.
Why, thank you!
Huh?
Energy can be transferred from one place to another. That's what happens when you touch a cold metal doorknob.
The heat energy is transferred from my hand because metal is a good conductor of heat. Cool!
Literally! We've also seen that a battery can release electrical energy, and that comes from chemical energy inside the battery.
Sounds like more than one type of energy is involved in most processes.
Did you say sounds? That reminds me that applying one kind of energy to matter can lead to the release of another. Just think about plucking the strings of a guitar. That's mechanical energy.
And it releases sound energy. How about that?
Interactions between matter and energy are so important to our everyday life. When you use a flashlight,
You convert chemical energy to electrical, light, and heat energy.
when you listen to the radio,
You convert electrical energy to sound energy.
when you clap your hands,
You convert mechanical energy to sound energy.
and by using solar panels.
You convert light energy to electrical energy. As you know, light is my favorite kind of energy. Light can be reflected with a mirror or a still body of water.
And sometimes light is absorbed. That's why a black car gets hotter in the sun than a white car. It absorbs more light.
I never really thought about why that happens before. It's fun to take a closer look at things.
Oh, look, Marko, he's bending light.
Huh?
That's right. Light bends when it goes through the magnifying glass to make a larger image. The same thing happens with binoculars and optical telescopes.
Light can also be scattered. In fact, the sky looks blue on Earth because oxygen molecules scatter the light.
Thanks, everyone. You've really helped me study for my physical science test. But now I should get back home.
Okay, just close your eyes and repeat after me.
That'll never work.
Come on, try it. There's no place like home. There's no place like home. There's no
place like home. There's no place like home. There's no place like home.
See you next spring! Hey science fans! You can download the practice physical science test at my website. Just visit www.markothepencil.com. Ciao! I'm Marko the Pencil. Take some tips from me. To do the best on your test, here are some strategies. Take a big breath and let it go. Taking a test shows what you know. Eat something healthy, but don't overeat. When you mark your test, be sure to be really neat. the night before. Get a good night's rest so you can do your best on the test. Read the questions carefully, and here's a tip to use. Eliminate wrong answers before you choose. Stick around and I'll show you some more so you can make your very best score. Yeah! And now that we've reviewed some of the material from physical science, let's see how well you might do on a sample test. For those of you following along, you might want to use pause when a question first comes up to see if you can choose the right answer before Kevin. Let's start with a question about safety that you might see on a science test.
1. Students performed experiments with 3 beakers of salt water. They placed the first beaker over a magnet. They poured the contents of the second beaker through a funnel lined with a coffee filter. They heated the third beaker on a hot plate. Which of the following should the students avoid while doing these activities? A. Read through the steps of the experiment and understand them. B. Tell the teacher if a beaker accidentally breaks. C. Pull the electrical plug of the hot plate out by pulling on the cord. D. Clean up your work area and wash your hands.
This is a place where it comes in handy to read the question carefully. If you missed the word avoid, you might fill in the first answer you came to that sounded like something you should do.
So I need to find the answer that is something I shouldn't do. That makes it easy to see that the answer is C. Pull the electrical plug of the hot plate out by pulling on the cord.
I agree. You should never do that. Now, sometimes you mark your answers right on the page with the questions, but this test has a separate answer sheet. Be sure you find out how your teacher wants you to mark the answers on your test. To make sure we fill in the right bubble, we'll put the test over the answer sheet just under the question we're answering, like this. The answer to question 1 is C. Now let's look at some test questions you might see about the scientific method.
2. Which question is testable in a scientific experiment?
Remember this, a testable question is not based on opinions.
Well, deciding which pet is better would be an opinion, so A isn't a testable question. B is also a matter of opinion. C. That's based on something I could observe. I could design an experiment to see if parakeets are more active at night. This is probably a testable question. D seems to be a matter of opinion, too.
Perfecto! You found the testable question out of the 4. So our answer for question 2 is C. Here's one more question that deals with the scientific method.
3. The chart below shows the results of an experiment designed to test the lives of 4 different brands of batteries. 4 new identical flashlights were used. Each flashlight got 2 D-size batteries of one brand. All batteries had the same expiration date. Which of the following statements is the best conclusion for this experiment? A. Brand 4 is the best value.
Let me shine a little light on something. We don't have enough information to reach this conclusion. To know if a battery is the best value, we would need to know the prices of all the batteries. Since that information is not in our data, answer A cannot be right.
B says, brand 1 has the shortest battery life. Looking at the chart, brand 3 has a shorter life than brand 1. This one's wrong too. What about answer C? Brand 3 is the cheapest battery. Hold on, we don't know the prices of the batteries.
That's right. Answer C is a bad conclusion.
Now look at the chart. Brand 4 has the longest battery life. we can be sure our answer is D. Let's look at some questions about matter that you might see on a science test.
4. Some very small things are listed below. Which is the smallest? Let's see. Atom, salt, plant cell, flea. I'm sure the answer to this one is A, an atom.
Great job!
Five. All of the following are considered mixtures except air in the atmosphere, a water molecule. I'm pretty sure that's the answer. The hydrogen and oxygen in H2O can't be separated with a physical change. Let me check the rest. The alloy of bronze or salt water. A, C, and D are all mixtures. We should mark answer B.
Excellent! What? Oh, I was feeling in the wrong bubble.
Now what are we going to do?
Don't worry. I'll erase it completely and neatly, so our correct answer gets counted.
6. Which action will result in matter with new chemical properties? Melting is a state change. That's a physical change. Burning is a chemical change, but I'll check all the answers. Sharpening a pencil,
Occasionally I need to sharpen up before a test, but that's not a chemical change.
And D, all of the above can't be right. So the answer is B, burning a log.
Super!
Seven. Logan tried to put a cookie sheet into the preheated oven without a potholder. Logan burned his finger on the metal rack in the oven. Why did Logan's finger get burned? A. The metal rack conducted heat to Logan's hand. That's true. B. Logan did not have a potholder to insulate his hand from the metal rack. That's true too. C. Logan did not follow proper safety procedures.
If he had, he wouldn't have gotten burned.
So the answer is D, all of the above.
Awesome! You remembered about safety as well as conductors and insulators of heat. And now for the last question on matter.
8. Some students were studying the properties of water. A beaker containing 150 milliliters of water was placed on one hot plate. A second beaker containing 300 milliliters of water was placed on another hot plate. At the same time, both hot plates were switched on at the same setting. After 12 minutes, both beakers had boiling water in them. Which of the following will be the same for both beakers? A. The temperature at which the water boils. The boiling point for the water in both beakers should be the same, about 100 degrees Celsius. This is probably the correct answer. I'll check the other ones to be sure. B. The time it takes for the water to boil.
Something we didn't talk about earlier was the difference between temperature and heat. Heat is thermal energy that can move from one thing to another. Temperature is a measure of the average energy of the molecules in matter. Because we have different amounts of water, it will take more heat energy for the larger amount of water to reach its boiling point.
You mean it will take longer for the beaker with 300 milliliters to boil?
Precisely.
That rules out B. C says, the volume of water left in the beakers. No way! The beaker with less water starts boiling first. It will have even less water. And the question tells us that both beakers still contain boiling water.
You're good, you!
D. The water will physically change from a liquid to a solid.
Now that's just ridiculous. We'd have to put the water in the freezer to do that. Our answer is A. This next question reminds me of an experiment we did at the Electricity Learning Center.
9. Jarrell set up a science experiment with the following circuit to show which materials conduct electricity. When Jarrell touches both wires to the following objects one at a time, which will make the light bulb glow?
From our experiment, we can rule out the plastic comb, the wooden spoon, and the eraser.
But the bulb will glow with the nickel, because metal is a good conductor.
Our answer is D, nickel. Here are a couple of questions about magnetism.
10. Which of the following is not true about bar magnets? A. Bar magnets have only one magnetic pole.
Remember what I told ya? All magnets have two poles, north and south.
That's probably our answer then. This question is asking which is not true.
Smart, real smart. And those last three look true to me. Magnetic force is strongest at the poles. All magnets attract iron. And like poles of magnets repel each other.
Our answer is A. That's the only statement here that is not true.
11. Look at the picture of the electromagnet below. Which of the following is true about electromagnets? A. Wrapping the wire around the nail more times will make the electromagnet stronger.
Let's see if you are paying attention.
Answer A is true.
You got it, kid.
But let's make sure they aren't trying to trick us.
Good thinking. Look at B. If the battery is replaced with one of a higher voltage, the electromagnet will get stronger. That one's true too.
So is C. Electromagnets are temporary magnets.
The answer must be D, all of the above. These next few questions are about gravity and motion.
12. What could cause the gravitational force to grow stronger between two objects? We learned that the two factors that affect gravity are mass and distance. That means A is correct. And so is B.
But look at D, nothing. That's just sad. Our answer is C, both A and B.
13. Mia has water in a wheelbarrow. She's pushing the wheelbarrow towards a tree to water it. Mia stops suddenly to avoid running into a kitten, and water spills over the front of the wheelbarrow. The water spilled over the edge because of A. Friction. No, the friction between the water and the wheelbarrow wouldn't make the water go over the edge. B. Inertia. I think this is our answer. An object in motion tends to stay in motion, but let me check the last two. C. Heat.
We're getting colder.
How about D. Acceleration?
That's a little tricky. Mia decelerated rather quickly, but it was inertia that caused the water to keep moving and go over the edge. Our answer is B.
I wonder if the kitten got wet.
I'm thinking yes.
14. If a ball is rolled across the grass on a soccer field, the ball will slow down because of A. Friction, B. Inertia, C. The speed of the ball, D. The acceleration of the ball. I know this one is friction because of Tara's explanation.
Sounds good to me. Let's look at some test questions about light and energy.
15. What two forms of energy are released when a newspaper is burned? You see fire when a newspaper is burned, and we learned that fire releases light and heat energy.
Is that one of the answers?
Let me look. Answer A says light and heat. The other answers can't be right. They all have electrical as one of the released forms of energy.
Fantastico! Let's look at one last question.
16. Leila noticed that the ribbon in her hair was coming untied when she went to feed some ducks in a pond. How did she see this? A. The pond absorbed light from the sun.
The pond may absorb some of the light, but that's not why she would see the ribbon.
B. The ducks bent the light with their bills?
I doubt that's what happened.
C. The smooth pond surface reflected light. I think that's our answer. But let me check the last one. D. Waves on the pond scattered light.
That's also something that can happen, but scattering the light rays would not allow Leila to see the untied ribbon. She saw her reflection in a still part of the pond.
That means our answer is C. Hey science fans! You can download a practice physical science test at my website. Just visit www.markothepencil.com. Ciao!